We are starting exponents, and first we need to know what an exponent is, okay? There is a base. The small number on the bottom is the base, okay? And a power, okay? The number up in the corner that's little is the power, okay? If we want to rewrite the exponent using repeated multiplication, we would multiply the base times itself as many times as there is the number of powers. So, okay, so number of times of the power. Okay, so if we had 3 to the 4th, we would rewrite it going 3 times 3 times 3 times 3. 3 times itself 4 times because the power is 4. Okay, so that's a quick review of exponents. Our first rule, because exponents follow rules, rule number 1 is same base, add the powers. Okay, same base, add the powers. So the 5 and the 5 are the same, so we can rewrite it as 5 to the 4 plus 8 power. What is 4 plus 8? 4 plus 8 is 12, so that is the same thing as 5 to the 12th power. Okay, if I were to write this out using repeated multiplication, I'm just going to show it over here. 5 to the 4th times 5 to the 8th. Well, 5 to the 4th becomes 5 times 5 times 5 times 5, right? And 5 to the 8th becomes 1, 2, 3, 4, 5, 6, 7, 8. Ooh, that's a not good 5. Okay, multiplying the 5 times itself 8 times and times itself 4 times. Well, that's just 5 multiplied times itself 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So we can rewrite that as 5 to the 12th. Okay, so this rule saves you that much time. Okay, let's see if we can use it again. Negative 4 to the 7th and negative 4 to the 3rd. Same bases, they're multiplied together. So negative 4 to the 7 plus 3, negative 4 to the 10th. Okay? Again, same base, 8 squared, 8 to the 4th, 8. If there is no power, there is an invisible 1. Okay, there is an invisible 1. So we have 2 plus 4 plus 1. 8, 2, 4, 6, 7. 8 to the 7th. Okay, now this brings us to rule number 2. Okay, power to a power. Multiply the powers. Okay, so using the shortcut, 3 to the 5th squared, so we multiply the powers. 5 times 2 is 10. Okay, now I'm going to show you why that works. Okay, so 3 to the 5th squared is 3 to the 5th times itself 3 to the 5th, right? Okay, and we can rewrite 3 to the 5th as 3, 3, 3, 3, 3. 1, 2, 3, 4, 5. And we can rewrite 3 to the 5th. 3, 3, 3, 3, 3. 1, 2, 3, 4, 5. Okay, and if we add all of those 3's up, it is 3 to the 10th. Okay, so notice the 3 to the 5th squared. When we multiply it all out, is 3 to the 10th. Okay, so negative 4 to the 5th to the 9th. We multiply the powers, negative 4 to the 5 times 9. So it is negative 4 to the 45th. Ooh, I'm really glad I don't have to write that one out. Okay, and that brings us to rule number 3. Okay, distribute the power. Okay, there is a note on this one. Does not work for items added or subtracted. Okay, so we are going to distribute the 4 to the 13 and to the 19. So it's going to be 13 to the 4th times 19 to the 4th. Since they are not the same base, we cannot do anything else. We're done. Distribute the 5, 135 to the 5th times 8 to the 5th. Okay, and I will show you how that works with this one because 4 is less than 5. Okay, so we have 13 times 19 to the 4th, which I can rewrite as 13, 19, 13, 19, 13, 19, whoops, 13, 19, 1, 2, 3, 4, right? Okay, and since we're multiplying, we can do that in any order. So I'm going to pull all the 13s out next to each other. 13, 13, 13, 13, 19, 19, 19, 19. Okay, and that is 13 to the 4th, and that is 19 to the 4th. That is why that one works. Okay, so you are going to use these rules for the ones below. Okay, do your best, and then I will show you how they work. Okay, do your best and show you. I will give you work to check your answer. Okay. Pause the video. Do them. Okay, same base, 3, 1, 4. Add them up, that's 8. Power to a power, multiply the powers. Power to a power, multiply the powers. Again, distributing the power does not work because they're added together. Okay, distributing the power because there is an invisible multiply here. So that becomes negative 3 to the 4th and x to the 4th. And then that negative 3 to the 4th becomes negative 3 times negative 3 times negative 3 times negative 3. Multiplying the negative 3's, 9 times 9 is 81. Okay, distributing the power. Okay, that negative just stays out front because it's not inside the parentheses. Parentheses are extremely important in this section. Okay, so that'll be negative 81 to the 4th. Okay, distributing the powers, there's 3 things multiplied together. Okay, 2 to the 6th, power to a power, so we multiply the powers. And then 2 to the 6th becomes that, and we multiply through, and we get 64. And we get 64, x to the 18th, y to the 6th. Okay, distributing the power. And then we have a power to a power, so multiply those and we get 28. And then we have the same base, so we add the exponents. And then we multiply out that 3 to the 4th and we get 81m to the 31st. Okay, and distributing the power, 3 squared, and then a power to a power, multiply the powers. And then 3 squared is 9. And then 9 times 4 is 36. And then we have the same bases, so we add the exponents. Okay. Okay, find the missing exponent. Well, we need x to the 6th times x something equals x to the 12th. Well, we have the same base, so we would add the exponents. 6 plus what equals 12. So what does that question mark have to be? Well, it has to be, obviously, 6 plus question mark has to equal 12. Subtracting the 6, we get question mark equals 6. Okay. Power to a power, we would multiply the powers, so we have x to the 4 times question mark equals x to the 12th. 4 times what is 12? Well, question mark has to be 3. Okay, and then we would distribute the power, so 3 cubed z question mark times 3. Power to a power, we would multiply. 27z 18. Okay, 3 squared, 3 cubed, 3 times 3. 3 times 3 is 9, times 3 is 27. So that would be 27, z question mark times 3. So what times 3 is 18? Well, 6, of course. Okay. The metric system has names for very large weights. A gigaton is 10 squared times the weight of a hectaton. 1 hectaton is 10 squared tons. Write 1 gigaton in tons. Okay, so we have 10 squared, okay, the gigaton, times the weight of a hectaton. That's really hard to say. And a hectaton is 10 squared tons. So that is the same base, add the powers, so it's 10 to the 4th power tons. Oofda. Okay, 1 teraton is 10 to the 9th, 10 to the 9th, times the weight of a kiloton, and a kiloton is 10 to the 3rd. So we add the powers, 10 to the 12th tons. Ooh, I thought 10 to the 4th was bad. Okay, and 1 exaton is 10 to the 6th. 10 to the 6th. Oops. Should probably write it as power, huh? Not 106. Silly. Okay, times the weight of a teraton. Well, isn't a teraton 10 to the 12th? Didn't we just find that out? Okay, 10 to the 12th. So that's going to be same base, add the powers, 10 to the 18th tons. Oy. Okay. Wall mural. You are designing a wall mural that will be composed of squares of different sizes. One of the requirements of your design is that the side length of each square itself is itself a perfect square. Okay, if you represent the side length of a square as x squared, write the expression for the area of a mural square. Well, in order to get the area, we need to take its length times its length, and if it's a perfect square, that means the side lengths are the same, so x squared times x squared will be x to the 4th square units. Okay, drawing a picture, x squared, x squared. Okay, find the area of a mural when x is 5. Well, 5 to the 4th, putting 5 in for x, that is 5 times 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is 25. 25 times 25 is 625. Square units. Okay, find the area of the mural when x is 10. 10 to the 4th. 10 times 10 times 10 times 10. The easy thing about tens is you just add up the zeros. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay, and comma, square units.